Hey y'all. Today's objective is recursive equations. Make sure you get this vocabulary down. Recursive equations. It's a little different. You probably never heard of. First word, terms. Terms are numbers or elements in a sequence. So you'll hear me refer to terms like term 1, term 2, or the first term, the second term, the third term in a sequence. A recursive equation. An equation that shows how to calculate the value of the next term in a sequence from the value of the current term. So you're going to determine the next term from the current term. An explicit equation is an equation that tells how to calculate an output value based on a given input value. So they're similar yet different. We are going to primarily, today, be talking about recursive equations. But you will eventually get to explicit equations. The main difference is in a recursive, you get the next term from the current. So you take the current term and you get the next one. The current term and the next one. An explicit equation is an input-output, where you have an input and you're going to get an output. It doesn't necessarily mean the term and then the current and the next one. It's just any input gives you an output. Alright, so to write a recursive equation, we're going to use this format. And it looks like this: start at, and then you're going to put the blank, your first term, your starting point, your starting number. And then you're going to use this as a recursive equation format. Next equals now, and then blank. Whatever you do to the number, add, subtract, multiply, or divide, that's going to go in this blank. And then the starting number is going to go here. And in this lesson, I'm going to show you how to write a recursive equation using sequences, tables, and visual patterns. So we're going to have examples on these on how to write a recursive equation. Write a recursive equation from the sequences. So A, B, and C. We have 3 problems. I have a sequence of numbers. So in this sequence, 5, 10, 15, 20, you've already probably figured out what the next terms are going to be. So when you start, here is our recursive equation. We start at 5. So that's where we start. Start at 5. And our equation, next equals now. So how are you getting the next term in each sequence? 5, 10, 15, 20. The next one would be 25. The next one would be 30. And you can see it's plus 5 each time. So it would be next equals now plus 5. That is a recursive equation. Next equals now plus 5. B, 2, 4, 8, 16, 32. This one is a little bit different. So can you figure out what is happening from each term to the next one? Because remember, a recursive equation takes the current term and goes to the next one. So right here you could say plus 2, but this is not plus 2. So you could say times 2, and is this times 2? 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So it's times 2 every time. We start at 2, because I'm starting here at 2, and then our equation is next equals now times 2. C. You try C. I want you to pause it, see if you can write a recursive equation. 30, 28, 26, 24. So write a recursive equation and then press play when you're ready to see the answer. So from here to here, minus 2, minus 2, minus 2. So we're starting at 30, and our equation is next equals now minus 2. All right, I hope you got that one right. So this is with sequences. All right, so example 2 says use the tables to write a recursive equation. We're going to be using tables. It's the same thing, but looks a little different. Over here you have the term. The first term, second term, third term, fourth term, fifth term. This just helps us keep track of it, but we have to look at the value. So when we write our recursive equation, we're going to start at, so our first one is start at negative 3. That's the first starting point. It's the first term. This is not where we're starting. This is just the first term. And next equals now. We have to figure out what is happening from our term to the next term. Term 1 to term 2. Term 2 to term 3. So from the current to the next. Well, as you see here, negative 3 to 6, you might think, oh, plus 9. But 6 plus 9 is not negative 12. So it's not plus 9. Maybe it's multiplication. So negative 3 times 2 would be negative 6. So maybe it's times negative 2. Negative 3 times negative 2 is 6. 6 times negative 2 is negative 12. Negative 12 times negative 2 is 24, and so forth. So figuring out the pattern is one of the challenges. So now, next equals now times negative 2. All right, example B, our terms and our values. So we're going to start at 52. And from 52 to 46, 46 to 40, can you figure out what's being done, what the pattern is for each term, the current term to the next term? And it's decreasing, so I wonder if it's minus 6. 52 minus 6, minus 6, minus 6, yep. So next equals now minus 6. Again, the toughest part is going to be figuring out that pattern. All right, so example 3, use visual patterns. I have a visual pattern, not necessarily a numerical sequence, but a visual pattern. Triangles, all right? And the term is the n. N, this is the first term, the second term, the third term, the fourth term. It also represents the number of triangles. 1 triangle, 2 triangles, 3 triangles, 4 triangles. The P stands for perimeter. That is the value that we're looking at. That's what we're going to write a recursive equation from the perimeter. So over here, start at 3. Next equals now. So from perimeter 3 to perimeter 4, perimeter 4 to perimeter 5, and perimeter 5 to perimeter 6. What is the pattern that's happening to each? 3 to 4, 4 to 5, 5 to 6, and hopefully in your brain you're thinking plus 1. So my equation is next equals now plus 1. Start at 3, next equals now plus 1. The perimeter is the outside side. So right here we have 3 sides. Right here we have 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So that's where the perimeter is coming from. All right. Now, pause it, get this down, it's a lot. In this example, again, it's a visual pattern, but I'm showing you the perimeter and the area. So we have squares. N is the term, first term, second term, third term, fourth term. It doesn't mean number of squares, because this is the second term, but there are 3 squares. Same thing, 1, 2, 3, 4. We have to look at the perimeter for our equation. The perimeter is here is 4, because there's 4 sides. The perimeter here is 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the perimeter is 12 and the perimeter is 16. So to write our equation, we are going to start at 4. And then what's happening from 4 to 8, 8 to 12, and 12 to 16. Well, I'm hoping that you see it's adding 4 each time. So our equation is next equals now plus 4. This is for the perimeter. For the area, my first term is 1 and my area is 1 because there's 1 square. My second term, the area is 3 because there's 3 squares. This is 5 because there's 5 squares. Area is the squares, not the outside, but the square. So I'm starting at 1, and then from here to here, can you figure out the pattern from 1 to 3, 3 to 5, and 5 to 7? And that is plus 2. So my equation is next equals now plus 2. Again, we're going to practice this. This is all about recursive equations. And remember, you put it in this form. You start at, and then next equals now, plus, minus, times, divide.